Good afternoon, good morning, depending on where you are. Today, I'm talking about the relationship between chemistry, biology, physics, and mathematics. I guess it makes sense that it's very hard to speak of one without the other. Sometimes you can have more of one and less of the other, but somehow, if you are trying to become a scientist, you are trying to become a mathematician, a physicist, and so on, you have to learn a little bit of each of these things and then go deeper in one of them. Uh, Let me begin by speaking about chemistry, for example. And what is chemistry? Everybody talks about it. Chemistry is the study of matter in terms of the property, the structure, the relationship, or the reaction that happens when you put the two different things together. That is what is chemistry. And basically, when you talk about chemistry, you're talking about atoms, molecules, compounds, and how they do reactions. Is it how they bond together, the elements bond together, and so on. On the other hand, when you're speaking about physics, it feels like you're talking about something that is not related to chemistry, because you talk about the nature and the interactions that happens in the nature, and then you talk about energy production and consumption. You're looking at understanding the universe. That's what physics is about. But do you know that there is a connection between physics and chemistry? There is. Because when you think about it, you're learning about motion when you go into physics. You're learning about motion, about forces. You're learning about interaction between objects. You're learning about electricity. You're learning about magnetism. Light, gravity, temperature, pressure. Volumes. Shapes might come in and so on. But when you think about all of those, you could actually go a little bit deeper and see that there is a connection between understanding, for example, electricity and understanding of electrons, which is in chemistry. Let's go a little bit next and talk about biology. Biology, the study of living organisms. Yes, study of the living organisms, uh, and the interaction that happened between them, and how they reproduce, how they grow, how they get born, and so on. That's all biology does. But remember, biology isn't about the humans only. There are, plants, there are animals, there are insects, microbes, you know, dead things, and so on. So there's a lot of things that we cover in biology. But then when you think about chemistry and biology, and I think in many cases, people understand that you cannot understand biology without understanding some principles of chemistry. You cannot understand chemistry very well if you don't know anything about biology, because some of the things that are in chemistry, for them to make sense to you, you need to apply them in the living organisms and see how that actually works. For example, if you're talking about how proteins are made, for example, in the body, or how food is digested, how it breaks down. You have to have that understanding of chemistry, a little bit of chemistry, understanding of how the enzyme works, all of those things, the catalyst and things. So it's biology and chemistry are so much intertwined. But then, as we will see later on, there is a big connection between the chemistry, biology, and physics. Let's talk about the connection between chemistry and physics. Well, it makes sense that we're learning about, you're learning about because chemistry is covering is a study of the matter and how interaction between matter particles, become whatever, depending on what you're trying to put together. But there is also this part where for you to understand physics, you have to understand matter as well. How it's made of atoms and molecules and so on. Because when we're saying we're freezing water, for example, the action of freezing water, that's a physical, that's physics. Because you can freeze the water and you can unfreeze it. But when you think about the arrangement of the molecules within a frozen water, then that goes back to chemistry. What are molecules? How does the distance between a molecule and the other in the same compound alter the state of the matter that you're trying to study? See how there is that interrelationship, the intertwining between the physics and chemistry. Well, I already spoke about the relation between biology and chemistry and physics, but is there any relationship between biology and physics? Yes, there is. Think of when we talk about biology and the study of life and organisms and living organisms, you can already think about if I wanted to learn about movements. I need to know where energy is going to come from. So the production of that energy and the consumption of that energy, and then energy is going to make something work. That it's going to make somebody move, or a muscle contraction. What is that? We're talking about motion here. We're talking about forces here, and that's physics. So there's something called electrophysiology, for example. When you think about how minerals in our body system um, make create some electricity in our bodies. It's very hard to explain what electricity is in these terms. Like when you have different charges on the inside and the outside of a body system that create some current, some stimulation. No, that's the same principle that govern the electricity as we know it. Except, of course, in electricity where there's power, the the, the current, the electrons are flowing continuously with the electricity being produced continuously, whereas in the body cells, in the cell, in the body systems, it is we need it now and it happens and then it stops. It can continue. It's on and off and on and off. Yeah, it's not, the purpose of now is not to explain every little bit of these things. It's just showing how these things are interrelated. And now bringing the three things together, chemistry, biology, and physics, then we talk about where they actually meet. Well, yes, they all meet on mathematics. You cannot understand biology if there is no maths involved. You cannot understand chemistry with no mathematics. There's no physics with no mathematics. So that's really an easy one to put out there. Of course, when you're learning biological processes or chemical processes, the mathematics that you need are not the same. Is not the same as the mathematics that you need for physics. But it's all mathematics because there's basic maths that you need for biological sciences, and some advanced math that you need for chemistry, and then more advanced math that you need for physics and so on. But I want to hint that mathematics is really and underpins many of the sciences that we cover. And of course, all the three are sciences, and they all deal with matter, of course, energy. When you think about technology, whether you're talking about the technological tests that happen or the designs that are done, everything has to have in mind the biology, the chemistry, and physics in many cases. Even when you talk about computers, for example, well, it doesn't look like it's got any chemistry. Obviously, it doesn't look like there's a chemistry, but when you think about the choice of
wires that I used and all the chips that I used. Those are elements that were chosen because of their properties, their chemical properties, and maybe their physical properties too. But remember, as you do your computers, for example, when you're programming a computer, there is a there's a use of mathematics. There is a use of physics. And when you think about how that computer is going to be operating with the people that surround it, when you think about the radiation that it could emit and then remove that and so on, you think about the biology. So somehow, they omit on this technology. And then there's something called biophysical chemistry, which it combines chemistry, biology, and chemistry in physics in understanding the way things work. For example, when you try to study proteins and how they're made, that is a little bit of the biophysical chemistry. But I'm not going to go into a lot of details here. I just want to highlight that um, this is what I've been thinking about. Where do they actually meet? Are they intertwined? Are they related to each other? Are they cousins or brothers and sisters? And so on. So what could you actually be learning in biology? In biology, we learn a lot of things. We learn anatomy and physiology, we learn zoology and botany, so that's the study of the animals and the plants. You can learn about the marine biology, so the fish and other things that live in the oceans and seas and rivers. Other people have gone on to learn things that died a long time ago, so that's paleontology. And we're learning about biogeography, which is the study of why a certain group of animals live here and not there, why people in this part are like this and the other part people are in what they are, in their area. So they use the use of geography as related to biology and the living in terms of geographical locations. We learn microbes, we learn genetics, we learn immunology, and so many other things in biology. So biology is very vast. Nobody can be like a someone who knows everything about biology. Biology in general, and then the specific areas that you concentrated your study on, but you cannot really understand the whole of biology. Plus, as we believe in biology, that there's an evolution, so things are keep evolving and changing, and there's new discoveries and so on. So really no one can say that I know everything about the whole thing. It's not possible. Now, in chemistry, although I've made just like a small thing, it's not that small. There's too many things that you can do with chemistry, but in chemistry, there is organic and inorganic chemistry. That one we can go into small details, but not necessarily now. You have physical and analytical chemistry. They all deal with different things, but I'm not going to go into the details either. I just want to show you that it's not just chemistry. There's more to chemistry than what you study in primary school and secondary school. Physics, on the other hand, is maybe another hand for another, very funny science that it touches almost everything, especially the bigger things, not the small one. It doesn't go into it's not like a chemistry where it goes into the beginning of things, where is everything starting from, as if you divide as in dividing the matter into smallest parts and then study those small parts to understand their nature, the structure, the properties, and composition things. You are actually looking at the sun interacting with the moon and the earth and all those things, and you're looking at how a car is going to collide with and a meteor or an asteroid is going to collide with us on Earth and then destroy everything, the volcanoes and everything. That's part of physics. You're learning about magnets. You're learning about the heat and heat production and all the dynamics that surround that. You're learning about relativity, the theories of relativity. You're learning about astronomy, cosmology, and so on. So that's
in short, things that you could do with those sciences. Now, I just want to bring this one together as in a diagram that explains the relationship between physics, biology, mathematics, and chemistry. And I'm sure all the terminologies that I use here are very difficult. I don't expect anyone to know, but I just want to give you like a visual representation of that relationship between these very crucial science things. With those, I want to thank you very much and wish you good. Thank you. You were with Belthrand.